So I won't be using a lot of my slides because I did bring our product deck with me, and I'm going to talk a little bit about our journey so far in making a product like a database and making it in India and how difficult it has been. So we started off like BlobCity was a simple domain name. I wanted each and every like variant of it, like so blobcity.com, .org, .co.in. We purchased everything in 2008. This was 4 years before we formed BlobCity as a company. So, and we took this domain and we were trying to build a social network of our own. By 2010, we changed the idea. We said we're not going to build a competing social network to Facebook. We're going to build a network that integrates all existing networks. So we were pulling in data from Facebook, Twitter, LinkedIn, and Orkut at that time into a single feed and giving users a single view to access all of their social content, which is delivering your news feed in 3 seconds. Very soon, the system actually started to slow down. Like we launched this like it was a private launch. We had a few folks use it. It was not scaling up. Like we were using MySQL database at that time. I'm pretty sure MySQL can do way better than how much it did for us, because I think we didn't really know how to configure it the right way. Okay, so we said we really need a proper data system to store all this data in one place and deliver higher output, like higher performance than what we were already getting. So our single intention was to have a 3-second page load, but pull in data from Facebook, Twitter, everything, and we couldn't do a real-time API call. We had to save the data in the system. So we started building a database of our own. It was not really a database. It was a proprietary storage system, highly specific to our own requirement, which is get a 3-second feed load. And we thought we'll do it in 2 months. Honestly, it took us a year and a half to build it. Okay, by the time we had reached like end of 2011 and 2012 was just starting, and we said this no longer makes sense because Orkut was nearly going shut. And there were a lot of protocols being added in place, like security measures, to not be able to pull data from the APIs of social networks. So we finally had to say that we're not going to do this. We already had a small consulting business where we're consulting with large corporates. That's how we were making money to sustain the development team. We decided to grow that business itself. Now, one of the members in the team that I had just took the data storage engine that we had and put some sample. He actually took a benchmarking tool, put test data in it, and benchmarked it against MySQL. Now, we were way, way, way faster than MySQL as per the official benchmarks. So we realized that if MySQL is has such a large user base, then our product very likely will have a user base. So we formed a private limited company, and we said we're going to do this. We're actually going to become a database company. And the database was not really a database. It wouldn't take SQL. It stored nothing more than a simple key-value pair. And it is very, very specific to saving our type of data. But there's one unique thing we did. We made it flexible to store any format of data. Because we knew that in future, other social networks could bring in, we had to store like image data, video data, all of that, but we might want to process it inside the product. So we made it completely flexible. So as of today, where we stand, we actually have a database. It's called BlobCity DB. And BlobCity was the name given to the social network. We are a product that natively stores and processes 17 different formats of data. That includes JSON, XML, images, video, log files, structured, unstructured, anything. And you can store this, and when I say store it, not just store it, you can actually store it. The product understands these formats of data natively, and you can have all of these formats sit in a single table at the same time. So you could create one collection, and you could put one record as JSON, second as XML, and you could still fire a SQL query over it. So over the course of the years, we started to add SQL support, and we have had some fabulous tech guys work for us to build a database. It has not been easy to code this out, because it's one set of a problem to actually configure a shard on a system that supports sharding. And it's a totally different thing to write the code that does the sharding system, and also do distributed transactions with two-phase commit protocols, and give asset guarantees on the data that you have with all the level of testing. It is a mammoth of a task to actually achieve. It's no way easy. If I had the choice of doing it again, I seriously wouldn't do it again. right? It's not a project I would simply pick up again. I would do something simpler than what we have achieved here. But we came a long way into doing this, and our product was always proprietary. We went out to companies and we said, you have a performance problem with your database. We will give you a database to solve your performance issues. We'll also do the implementation and migration and all of that, and we'll charge you for those services. We didn't charge our customers for the product itself. We said we're going to give you the license free, but it was proprietary. Customer said, I don't really care. I want the specific output to be achieved in terms of either performance or capability. As long as you give it, I don't really care what type of database you use at the back. So we said, fine, we'll do this for you. That's how we made money for almost like 4 years in a company, and the product was still being matured. It was simply in beta. It simply had a lot of bugs, right? You would put it in the customer. We've seen customers wherein the data is lost, and the data loss has been permanent. And it took us a lot of effort to actually make sure that this never, ever happens again with any customer. So we went on to building it. We raised some rounds of funding. We got funded from IIM Ahmedabad as a seed round of funding. We were part of the NetApp Accelerator after that. And somewhere down in the journey, we realized that if we actually want to do this at scale, having a proprietary product is extremely complicated in this landscape, because it requires to have a large enterprise sales team to convince a company to start taking your product and using it. And selling something like a database is not easy. Even if you put a zero price point or charge a small fee, it's simply not easy to convince somebody for an enterprise software. So we realized that if we as a company have to survive and we want to be proprietary, there's only one way of doing it. We have to charge insanely high amount of money for the software so that one deal that we crack with one company pays off for the entire year. Okay? Because if we don't do that, we had a problem, because we're only cracking one deal a year anyways, right? So we said this is not going to work. We could either do it that way, or we simply go open source and go mass market and allow everyone to use our technology. In 2018, against all the advice that we had, okay, we were seriously, every single person, we met a lot of people before we open sourced this. Every one of them said, if you want to sell your company at some point in time, you're not going to be able to do it anytime soon if you're open source. You can sell your intellectual property today to someone else who can find use of it, because you have these storage algorithms, clustering algorithms that are very, very specific. It's like we created these, we conceptualized this, and that is true intellectual property. And they said, you can actually sell this to someone. It's going to be valuable to someone. If you open source this, you won't be able to sell it because you're losing that IP. Directly, it's available to everyone to use. So we thought about this a lot, and we said, we really didn't actually come all this way to make a company to sell it to someone for some small amount of money, or it could be large, substantial also. We said we really want everyone in the world to actually use this product and benefit from the technology. So in 2018, late 2017, 2018, we just took our code and put it all on GitHub. It's been a good journey. Adoption of open source is also not that easy. That's what we realized. We thought we'll put it, everyone will take it. It doesn't work that way, right? And nobody actually realizes that you put your code on GitHub. There's just too many projects there. So you have to do, after that, you have to go on to Hacker News. You have to do a lot of hackathons. You go on to Hacktoberfest, all of that. You simply have to keep product hunt, and you still have to do that. We still keep doing that to keep getting open source contributions. We have contributors today who've contributed in the open source project, but it's also not an easy project to start with. So the learning curve is pretty steep. If you want to write your first line of code in a database, it's not easy for someone to start. We went on to building it. The revenue model today for us is very, very simply put. It's support contracts on the product and customized data science. So today the database is actually the de facto database that a lot of data scientists use for their data science needs. It's extremely easy to configure, power up. Sharding and all is completely managed by the product. You can fire commands over CLI, and then it'll connect the nodes. You don't have to write these config files to actually get a cluster set up. We kind of made it as easy as it can get, and it's pretty fast. We are the only database that natively stores 17 formats of data. An example of this is if you go and do a ATM transaction with a bank, essentially the ATM machine is capturing a video feed, and your backend system is capturing a transaction log. if you want this transaction log and your video feed to be pulled out in a time synchronous manner to look at all the activity that happened alongside that transaction, you can pretty much do that with BlobCity database because it understands your video, it understands your transactional data, and it can get you the view of your entire organization at a single point in time. So you can query it for that specific instance. So, thank you. So this is what you've been doing. Today, we later on went on to saying that we want to actually make this capability of the product available to everyone, not just in open source form. So we launched our cloud offering, and I have some slides on this. Let me see this. Okay. I'm going to script through most of this. So these are all the formats that we support today in the product. That includes, you can put in PowerPoint presentation, SQL dumps, syslogs, zip files, Excels, virtually anything you can think of. And when I say Excel, I don't mean normalized Excels. These could be formatted Excels, which are pretty looking, good for human reading. They actually have cell color in the background. And you can fire a query saying, get me summation of column C where cell color is green, where background color is green, right? Which you can't do it. So when we store Excel, we basically mean we store it. We fully interpret it and store it. Like all of these formats are completely interpreted. So it is, of course, full SQL support, JDBC, ODBC. It is completely asset compliant down to the record levels. It is completely DML supported. It's real time also. We have a database engine that stores data in memory if you want it to be fast. We have an engine that stores data on disk. Both options are supported. We are very, very fast for on-disk storage, but it comes with the compromise of we bloat up a little of disk space. So we realized this trend back in 2012 that storage space is becoming really, really cheap. And it's no longer going to be, like compression is no longer the biggest of the problems because the incremental cost on storage is very minuscule compared to your general infrastructure cost. So we give you really, really high performance storage engines as compared to a MongoDB or a Snowflake or any of these products. We are way faster in terms of how you store data and retrieve data. But it comes with the compromise that we actually bloat up the data. So our indexes are pretty fat in structure, but they give you insane amount of speed. So a typical architecture stack looks like you put BlobCity database as the de facto database. Our customers move data from other application databases into BlobCity. So let's say you have MarkLogic that primarily stores XML, you have Mongo that primarily stores JSON, but you want to mix this data together, you move it to BlobCity. So a lot of customers do that. They also bring in the structured data into BlobCity that creates a single platform where all your data can reside. From there, you expose your data to BI tools. You can run AI models and expose it to various departments. We give fine-grained access control over who has access to what data, and it's down to individual columns. So if you have an employee column, you want to say that only few people can have access to the salary column, that's pretty much supported. So you could fire a select star query on the employee table. If you don't have the necessary authorization, you will get all the columns except the salary column, right? So we kind of do that. And so a lot of customers use this in this manner to move data between systems. We also support Java and Scala-based stored procedures. So you can take your AI models that are written either in Java language or Scala language. I know that's not the most popular languages to use for doing AI. But if you use one of these two, we already support it. If you use Python or R, we are adding integrations for it. So it will be coming up soon. So this is fine. I'm just going to skip through it. We are open source on GitHub at this URL, so you can please feel free to check it out. We do encourage active contributions. And if you're a contributor, we will offer you like unlimited amount of support for any questions you have. So you can just join our Slack community, and we'll help you out with anything you need. I'm just going to, yeah. So we went on to actually increase our revenue with the cloud. Like cloud is a big thing, and we wanted to make this available to a lot of organizations. So what we did is we launched this enterprise cloud somewhere down the line after open sourcing the product. And the reason we call it enterprise cloud is because it's not retail. It's not for an individual user to go and start purchasing and using it. It's primarily meant for companies, and that's because the price points are higher. And this is a way in which we make a lot of money today. But what we did is we actually recognized this trend that people store data only for two purposes, right? the first and only purpose is you want to analyze the data at some point in time in the future. Second is you're legally required to save it for compliance. Okay, there are only one of two reasons why someone saves data. If you're saving it and you don't want to analyze it, I just don't understand why you're saving it. Right? You might not analyze it today, but you'll analyze it at some point in time in the future, is my understanding. Right? So we launched a system which is multi-tenant. Right? So the product, it's a single instance of the product. Of course, different instances occur different data centers. But in a single data center, a single large cluster of BlobCity. Strict permission control so that one organization cannot access data of other organizations. That's already built into the system. It's pretty much like a Gmail service where unless somebody cracks your password, they can't actually take your data, but you're using the same shared service. So, and we said we're not going to charge our customers for the amount of data they put in. Okay? There's literally no charge. You can put in unlimited amounts of data. We don't meter it, we don't count it, we don't charge you for it. We will store it at our own cost. But we only charge you for the selects. That goes to the philosophy that if you're storing data, you are going to analyze it. And when you analyze it, we'll make money out of the analysis, not out of the storage itself. So a lot of companies do not embrace the cloud because there is a fixed cost associated with just simply storing large quantums of data on the cloud. And we said we want to make that fixed cost of storing the data zero. So you don't pay for it. We'll figure out how to store it. We will archive the data if we have to. When you're not using the if you don't use the data for more than 30 days, we will actually super compress it and archive it on like nearline storages and really cold storage systems to save on the cost. And when you want it again, it'll come back to you. It'll just take you a few more seconds before you can get the data, right? So we figured that out. It's pretty much transparent. You don't have to do anything there. If you're not using the data, we will compress it. And for whatever you select, we charge you for it. Now, how does the pricing look? It's kind of pretty simple. So we said there's a light plan, and that this is why it is enterprise only. It starts at no less than $500 a month, right? And we have several companies paying this as of today. In $500 a month, you can select 100 billion records. Okay, unlimited users, unlimited data on all plans. 100 billion record selects. Now, what does this record select actually mean? Is if you fire a select query on a table that has 1 billion records, okay, and the select query is select summation of a particular column on a table that has 1 billion records, the summation effectively returns one record, right? Although you scanned 1 billion records, you summed up 1 billion records, but you returned only one record, which is the effective sum of the 1 billion records. We count it as one record in the response. So it's only a data takeout fee, not the amount of data you analyze. So you could have 1 billion records in the table. You fire one summation query, which is going to scan through all the records. We charge you only for the one record that you took out. But if you fire a select star on 1 billion records, we will charge you for the 1 billion records because now you took out all the data that you put in, right? So it's very, very simple and transparent pricing. There are companies that have actually overshot the 1 trillion selects per month limit, right? So it goes to a higher plan. And they're very happy with it, that the fact that you can actually put in any type of data, and all of it can stay on the cloud free of cost. It could be a mix of videos, images. It's not just structure. It could be all the data that you have can just mix in together. So I think that is what we have. So at BlobCity, we're primarily here to take the data-driven decisions to the next level. Our product is used by a lot of data scientists when they connect their Jupyter notebooks or Python programs to BlobCity DB, and they fire queries on BlobCity DB. It's much easier to pick up images from BlobCity DB than actually pick them up from the file system for analysis, especially if you want to do analysis at scale. You can also write these models, run them on the cloud servers. We actually provide to our customers, we give them dedicated instances which they can use for data science purposes, which have a private network connectivity to our hosted cloud infrastructure, which is a database. So you get ultra low latency of communication between your application and the database. And yeah, so this is what we do at BlobCity. I think that's all I had for today. So if you have time, I'm open for questions. Okay.
That looks like an amazing project, quite amazing. The pricing plans are really curious, a little unusual also, I think. How do you imagine somebody bringing in terabytes of video blobs? How do you handle that?
We just lose money. We're not profitable with every customer.
Yeah,
but
but it works out overall.
it works out. The contention is overall, it's going to pay off. The cloud is, honestly, the cloud is still loss-making for us.
Right.
Even at those price points, it is loss-making.
Yeah, cool.
Yeah.
So who are the biggest users, and where are you getting maximum traction from? What use cases?
Quite a bit. We don't have a lot of banking customers, to be honest, because we're very skeptical of putting data on cloud. But we have a lot of customers in terms of retail, automobile, all of that. So we serve Jaguar Land Rover worldwide for their car pricing. We serve Underwriters Laboratories, which is a fire safety certifying company. If you take your laptop chargers and you flip them around, you will see a UL logo. They use our technology worldwide for fire safety assessments that they do. Then several others. Adidas is also a customer for retail analytics that they do on our system. And quite a few, some I'm not allowed to name also. But a lot of them actually use. So it's a wide sector of wide segment of users, but not a lot in the financial sector. We're still trying to figure that out.
Hello. Hi. Yeah. So the product picture is really great, but given that this is a FOSS conf, we would have actually liked some insight on how you built it and what are the, you talked about making your IP open source, right? So it's already in the open. We would have loved to know why your indexes are fat indexes. How do you structure? What do you do differently than any existing NoSQL DB where you can dump blob data, right? So I mean, we didn't really get that.
So I actually intentionally did not want to cover that tech. So,
but we would have loved to really listen to the tech.
I know. So I can still do it offline. There is open documentation available on our website. But if we have to go through how we store the indexes, it's kind of pretty complicated. But I can give you a good overview. So we support B-tree type indexes, hash type indexes, geospatial, and time series. These are the primary types of indexes that we support. All of these algorithms we wrote ourselves. And it's pretty open. There is no IP right now. So you can actually go to GitHub and you can look at our source code. You will find it in the indexes folder. You'll find all the implementations. And yeah, maybe when we have longer duration of time, I'll be happy to actually walk you through. Or you can just join a Slack channel, ask anyone from the team. They'll give you an overview of how the indexing works.
Nemo here. I was curious how you decided to pick the AGPL license. What was the thinking process behind that?
So that's a very good question. So we actually evaluated a lot of licensing types, primarily Apache. And what we came out with is we are in the business of making money. We need to make money, right? And that allows us to make a good product. So we wanted a licensing structure that makes sure that no one can create a commercial version out of the product that we have. Right? You can create a commercial version, but not a closed source commercial version. So the reason we chose AGPL v3, it works bidirectional. Okay, there's a disadvantage to us as well as a disadvantage to everyone else. So if anyone takes a source code and tweaks it, you're allowed to sell our source code as is at a price. If you make tweaks in it, you're allowed to sell those tweaks at a price as long as those tweaks are made open source. Okay? Now the same thing applies to us, which means I cannot ever have an enterprise version of the product. Right? If I change anything in the product, I have to mandatorily make it open source. We wanted to keep it that way so that we retain that control. Okay? We are enabling the ecosystem, giving it free to anyone to do whatever they want, but they cannot create a privately customized commercial version of the product. We didn't want that type of competition to foster. So we said we want to keep it AGPL. It comes with restrictions on us, but so does it come with restrictions on everyone else. Okay, anyone else?
One last question. Okay. Anyone?
I have two questions. One is who is the customer who is having maximum number of users and what is that count like? And do you have the containerized version of the database?
Oh yes, we are available on Docker. So you can take it directly from the Docker store. We have images on AWS Marketplace, DigitalOcean Marketplace, so you can just directly pick it up from there. I think the largest customer has, not in terms of data size, in terms of users that access a cloud platform, I think it's about more than 500 users from the tech team that access the cloud platform. They ingest, I think from a data standpoint, one of our largest customers ingests about 3 terabytes of data a day on our cloud. Each day they're putting new, and they keep analyzing all of the historic. It's mainly for report generation and some type of fraud analytic use cases.
Okay, thank you.